All right. Thanks again for coming to our Cloud Methods Working Group, Birds of a Feather. Today we want to give you sort of an idea of what's going on with the Cloud Working Group and get some discussion going and find out what your needs are. And so just let me explain a little bit about our working group. So we were started earlier this year to advance a Bioconductor's presence in the cloud infrastructure for genomic data science. We've been meeting monthly and discussing how we can help people to use the cloud and what our needs are. And a lot of us are in this room today, and we'll try to give you an overview of what is currently existing in Bioconductor and what we're talking about. And we'd like to help you to use the cloud and solve problems that you're trying to solve. So let's start by an introduction. Myself, I'm Jen Wokaty. My pronouns are they and them. I'm a core team member of Bioconductor, and I'm also a member of the Waldron Lab. My specific interest in the cloud working group is that I work on the build machines that developers use and might check to see how their packages are doing. And we want to kind of close the loop on the time it takes for a developer to assess the health of their package. So that's me. Who would like to go next?
Hi, I'm Brian. I'm a PhD student at Imperial, and I got involved in the Cloud Methods Working Group right as its inception, in part due to my involvement in the R workflows suite, which you may have seen yesterday, for GitHub Actions and making continuous integration as easy as possible for everyone. And yeah, I think I'll leave it there.
Hi, I'm Alex. I'm also on the core team. I also use they them pronouns. I mostly interested in cloud infrastructure as it relates to services that Bioconductor can offer. The workshop instance that we're using at this conference is one of the examples how we can kind of surface cloud resources that we have so that other people can use them in the community, but also interested in hearing how other ways in which that can be helpful to people. Yeah. And you wanna do a quick.
Yeah, hi, this is Erdal. I'm a data scientist at Microsoft Genomics team. I'm happy to be a part of the cloud working group. So I'm trying to share my experiences in the cloud side and create a usable content for the Bioconductor users. Thank you.
Thank you. Any other members who would like to just mention and introduce themselves?
Okay, I'm Vince Carey.
We are. I am also a member of the Cloud Working Group, and I think they've done a good job of illustrating some of the topics that the project is very actively interested in. So just sit back and listen now. Thank you.
Okay. So I just want to clarify what we mean by the cloud, and also what does the Cloud Methods Working Group actually talk about and think about. So there are many reasons why we'd want to use the cloud. And what is the cloud? It's some remotely accessed computational resources that you might use for processing or storage. And your motivation might be to reduce costs. You need a flexible infrastructure, or you need to scale. So in our Cloud Methods Working Group, we talk about anything that's remotely accessed. And also we include GitHub Actions as well. So we're going to talk about these a little bit more in terms of containers, cloud compute, and GitHub Actions to help developers and anyone basically interested in using cloud solve problems. All right. Would you like to speak a little bit more, Alex? And I can advance the slides for you if you'd like.
So I'm gonna first just talk a little bit about things that we already have, just resources that are out there, services that we already have out in the wild that you can use right now. So starting with Docker containers, a little bit about what Docker is for those who might not know. The basic idea is that you can ship with, we use Ubuntu as an operating system, all the system dependencies that you need to run a particular software. You have it all encapsulated in this, what we call a container, that is published to a registry online or a hub. And then when you want to run the software, instead of on your own computer and on your own operating system, having to deal with installing and downloading all system dependencies, installing Bioconductor, and then preparing your R environment, you can just download this container, run it. Whether you're running on a Mac, a Windows, or a Linux environment, it would be a standardized environment because you're running within the operating system of the container. And one thing also to note is that containers can also be run in singularity. So most people use Docker because that's kind of the more default, I guess, that people know about, and it is called a Docker container, but singularity is basically the same thing without needing root access. So basically, if you're in an HPC cluster, you can run Docker containers with singularity with a lot less privileged access. So resources that we currently have, we have the Bioconductor Docker image. You can find the source on GitHub at Bioconductor/Bioconductor_Docker. These get pushed periodically to two repositories. One is the GitHub container registry, which is directly in that repository. And then the other one is the Docker Hub. So they exist. We currently are using them in the workshop instance, for example. All containers are based on the Bioconductor Docker image, with then an extra layer adding the material and packages for each of the workshops. And then a little bit more complicated than that, if you want a little bit more orchestration, you're not just looking to get a quick RStudio session or a quick R session, but actually looking to deal with network policies, with volumes, with ingress resources, exposing Kubernetes is one way that you can do that in the cloud in a parameterizable way. So it is kind of wrapping those Docker containers with configuration and orchestration around them. I'm not going to go into too much detail, but if you go to the Bioconductor/Bioconductor-Helm on GitHub, you will find documentation there on how to use the Helm chart on different clouds, for example, and happy to also talk about it after. So one notable thing about the Docker containers, we have all system dependencies pre-installed for all 2,000 some Bioconductor packages. So there's an implicit guarantee that if you're using the Docker image, any Bioconductor package should be installable without you having to do apt install or any other system dependency installation for Bioconductor packages that are accepted into the Bioconductor repository. And the way we do that is by providing the system dependencies in the container. And then because we have all system dependencies there, instead of having to compile packages in R when you install them, we can use precompiled binaries because we know the environment is static. It's always the same environment, the Ubuntu that we chose. So that reduces installation time for packages from several minutes, which can end up being several dozens of minutes when you're installing tens or hundreds of packages, to a few seconds, because all it does is just download the precompiled binary and untar it, and that's it. There's no compilation needed. There's no GCC needed, and yeah. An evolution of that, which we hope we will have soon, is to also have Debian packages, so that if you're using on any Debian-based system, so Ubuntu or others, you would be able to get the binaries along with the system dependencies. So we want to eliminate this need of being in the Docker container where system dependencies are needed, and be able to just have the requirement of, if you have an operating system that we know, we will ship the binaries and the system dependencies for each package in Bioconductor. And then
Sorry, I want to just
Yeah.
add one thing. Another really beneficial, oh, sorry. Another beneficial aspect of the containers is, as a developer, you are often working on the day-to-day using the release version of all the Bioconductor packages, but you want to be ahead of the curve to know what problems are going to occur on the development version. So without having to reinstall everything back and forth, you can just make a Docker container, have the development version in there, or the release version, whichever, and sort of have parallel installations of all of the R packages in one machine. Yep.
Yep, that's a really good point. And on that note, also, if you want an old version of Bioconductor, say you want Bioconductor 3.15 when we're currently on 3.17, you can also pull the Docker image for 3.15, and you will have the environment that was the canonical one during 3.15, and you'll be able to install packages from 3.15. So if you want a package that was deprecated, for example, you probably shouldn't be using it. But if you really want to, because your workflow needs it, you can use the Docker images to not have to do things locally, but just pull an old version. Thank you for reminding me to say that. And then one last thing I want to talk about is the workshop, bioconductor.org. It's a new service that we have out there. It runs on the Jetstream Academic Cloud at Indiana University. So it's credits from the National Science Foundation. And we're currently using it for workshops, but would love to hear what other things people might want to do other than these short-term workshops in something like this service. And
Yeah, I should also just add, if we definitely would love this to be interactive as possible. So if people have ideas, suggestions, any questions, things that we haven't clarified, please feel free to interrupt us. The real goal of this group is to assess the needs of the bioconductor community and make sure that we're providing the tools, the infrastructure to make everything easier for existing bioconductor users and also attract more bioconductor users, people who are developers but just haven't necessarily contributed.
Right. Don't be shy. I will run the mic out for anybody who has a question.
Cool. Thank you.
I have one right now.
Oh, nice.
Thank you. I was wondering because I'm maintaining multiple packages, and one of my packages failed in one builder, but successfully checked by another builder. I just wondering, do we have the Docker image for the builder system so I can debug? I can know what exactly happened because it passed all my local tests.
I guess short answer is no right now. If you want for Linux, if you use the Docker container, it would be somewhat close to the BBS Linux builder. It's not identical, but you might be able to produce some errors there. But for the other operating systems, no, because the Docker images are all Ubuntu based. The part that we're going to talk about next with GitHub Actions is kind of our attempt to try to get in that direction so that there is a way to test on all the different operating systems and try to make them as close to the BBS as possible so that then you can have that simulation. But at the moment, no. And yeah, the Docker images would not help with that, unfortunately.
Keep in touch with us. Yes, that is definitely a use case for our work in this area to make sure you can reproduce the events in the build system.
Cool. So yeah, that leads nicely into the next section where one of our focuses is on GitHub Actions and really tailoring this to use cases for the bioconductor developers. And I should mention that we have a sub-working group that is specifically dedicated to this. There will be the hashtag to the Slack channel for the sub-working group. If you're interested in joining or participating in the conversation there, it's all in the Bioconductor Slack. So yeah, for those who aren't super familiar, GitHub Actions is basically a GitHub native way to implement continuous integration where you make your edits, you push it to GitHub, and it triggers a series of actions. And that can include things like checks, building from scratch. And this can be a nice intermediate for actually checking your package before you push upstream and distribute it to users through Bioconductor. So one of the main goals here is to incentivize developers, users, and journals to sort of adopt these standards in terms of automated continuous integration and checking. And one of the ways that we're trying to do that is, offering the ability to easily assess your package health, reducing installation time and troubleshooting, and also improving documentation and the accessibility and the findability of that documentation. So in other words, we're trying to build the gondola for you so users don't have to climb uphill, particularly when it comes to GitHub Actions, which does involve a little bit of YAML scripting. And so we're trying to make that as easy as possible. So yeah, and there's been a number of parallel efforts by myself, by Leo, by Mike Smith, and others who have been basically making different ways of implementing GitHub Actions as it pertains to Bioconductor packages. And one of the other things that come along with that are templates for people who are newly making a Bioconductor package. One example is template R. There's also BioC. Has several functions for making different elements of a R package template. Use This also has similar features. So yeah, just making it clear like what is available out there, so that users have all the options available to make package development as streamlined as possible. That includes tutorials as well. So yeah. Yeah, and kind of as I mentioned before, there's been a series of parallel efforts. We'd really like to, a big part of this cloud working group, and especially the GitHub Actions subgroup, is to bring all this expertise together, sort of harmonize and synergize our efforts so that we can work together in making tools and different capabilities that are very easy and useful for users, and trying to get, again, feedback from the community to figure out what the needs are, how people like using these tools. Yeah, and this is just several examples of some of those parallel efforts that we're now trying to harmonize more with.
So, okay. So in our working group meetings, we've been trying to discuss what are people's needs, and also how can we address those needs, and how can we sort of forge like a stronger path in the cloud for Bioconductor. And both Alex and Brian have talked about the different ways our current existing resources offered by Bioconductor and maintained by the core team, and also those that have been created by the community as well. And so, as Brian mentioned, with GitHub Actions, we're trying to sort of formalize this more and give it some structure and make sure it could be maintained in the future. And also, the subgroup for GitHub Actions will be taking that on more directly. And I'd also at this time, I'd like to invite Erdal to speak a little bit about benchmarking and what that is and how can that be a benefit.
Yeah, thank you. Can you hear me well? Perfect. So one of the things that I always thinking about is I have a cloud environment and I have a limited budget. So this is the usual scenario. And I need to know which VM family is the best choice for my analysis, from installing the Bioconductor packages to complete all my analysis. Therefore, we would like to create some kind of a guideline. If you would like to use cloud environments, it's not just for Azure, it can be for GCP, it can be for AWS. We can create a guideline. Hey, if you would like to install all the Bioconductor baseline packages, or if you would like to complete a specific analysis type, you can easily find what type of VM you need, including the CPU options, including the disk size and memories. So I hope it will be useful for the Bioconductor users who would like to use the cloud environments for completing all their analysis. And the second part is the security reviews. So it's actually, if you are working on a private network on cloud, sometimes you have an issue on downloading the sample data sets or installing the specific dependencies on the Bioconductor packages. Therefore, we would like to create at least some kind of a security review pipeline to check all the new or existed packages before make it available to the community. I know many people are doing these kind of reviews, but for the cloud specific users, we can maybe provide a pipeline and we can easily check the new packages, existed packages, and make it available on a secure network or secure platform. So this is the second item that we are working on, and we will be happy to have your questions about these two items too.
You can take it. So this is our current sort of focus right now, but I think since we're still a very new group, what's really important for us is to hear from the community. What are your needs? What are the problems you're trying to solve, and how can we help you? And how can we help you use the cloud and GitHub Actions? Sometimes I feel that, maybe as scientists, you have better things to do than to figure out how to install this specific thing, this piece of software on your package to solve this really complicated problem that only you can solve. So we want to help you to get there. So right now, I'd like to open this up for questions, and we'll try to respond and take notes so that we can continue the conversation and working to solve your problems. And I want to also mention that all of us are very open to collaboration, and please reach out to us. We're on the Slack. We're very, very active, and we have, yes, let's share. Let me just, let's throw this up. So you can reach out to us here as well. So anyone have questions or comments? Don't be shy. Yes.
So I very much fall on the comment side. So I just wanted to give some really positive feedback. So Alex, one, thank you for last minute helping me construct a workshop for this thing. It was really, really easy, and I was surprised at how easy it was. And it's probably, obviously, thanks to the work that you guys have done. That GitHub Action stuff was absolutely brilliant. So I fall into the category of a dumb scientist or researcher, and I just wanted to give you the positive feedback that that's brilliant and it was really easy to use. So thank you.
And I want to clarify that I don't think scientists are dum-dums. I just think you have better things to do. That's all I think. You want to get on with it. There isn't software yet for what you're trying to solve, but this software, solving that is a problem.
Out of morbid curiosity, what's a organization with huge packages and huge amounts of polls nightly doing on pricing? Are you pushing past the minutes for each worker on GitHub free tier, or are you guys planning on going into larger ones because we're using more minutes than you think you need?
So I think the biggest place right now that we're using GitHub Actions very extensively is building the binaries for the Docker images. We used to do it in Google Cloud, and to not have that bill anymore, we started doing it in GitHub Actions. We are using the free tier. It is basically dispatching about 6,000 jobs over 2-3 days. It only runs 20 at a time, but it dispatches them and they just wait queued, and when it's their turn, they run. We used to build weekly. So the fact that it runs over 2-3 days is kind of still good. I'm assuming maybe at some point GitHub is going to get mad for all the traffic and usage, but we are within the guidelines of what they do. And yeah, we just did it by basically serializing it so that we build one package, it's done, it pushes its binary, it frees up the worker, the next one comes in, and it just does that on a loop until they're all done. And then when they're all done, it restarts the cycle.
Just for the Linux build?
Yeah, no, we only do that for and not the build system Linux build, for the binary building for the Docker images. So far, we are talking about the idea of like kind of evolving / making a parallel build system with GitHub Actions, but that is probably in the future, probably not like very near future. But yeah, so far it is only the binary building that we do with GitHub Actions.
And I would notice that the binary building is for AMD Linux, but also for ARM Linux now. And the code base for that is straightforward enough that Alex was just able to hand it to me, and the ARM Linux builds are built in the same sort of process.
Yep, and the ARM binaries are not, well, actually, yes, on the note of the containers, as of 3.17, we also have ARM64 containers. So if you're on M1 Mac or M2 Mac, M-chip Mac, by default, you have ARM64. Previously, if you use Docker, it would use an emulator to pull AMD64. And that's why sometimes if you did computations, it would be very slow because it's using an emulator. So now we have ARM64 containers out there as well so that it pulls the native architecture. And 3.18 will hopefully most likely include the ARM binaries as well. So you don't have to do compilation in those containers either. Thank you for reminding me.
Yeah, I got it. So I know that there's a question online, but before we get to those, I just wanted to ask by show of hands, how many of you have used the cloud or are using the cloud? Okay, I mean, that's a very broad question. That's right. Like,
We're using Drive to see your talks and everything. That's the cloud.
okay, so for computation, let me be more clear.
Okay, computation.
Okay, and then how many of you are using GitHub Actions? Okay, is this for testing packages, building your documentation? Okay, I'm seeing some head nods. Okay, I'm just wondering. Okay, so we have some questions in the in Hopin, so I'm gonna read those and then pose the questions to everyone. So what are your thoughts on cloud vendor collaborations? Yeah, I think both of you are.
I'm not a representative of the cloud vendors, but I can give an example. So Terra is a great platform, and Terra can be run on GCP, can be run on Azure. We are not directly collaborating with as a cloud vendors, but you can probably in near future, you can just log in with the specific accounts and use the same infrastructures or similar infrastructures for the same tools. I think it will be same for the packages for the Bioconductor, but if he or she would like to hear anything else, so I don't have any answer about the collaboration between the vendors.
I guess from Bioconductor, or at least my standpoint from Bioconductor, I like collaborating with commercial clouds. I think it is generally very good and it helps do things quickly and in a very robust way. But I also like building cloud agnostic things so that they can be easily moved from one cloud to another. So Docker containers can be used on any cloud. The Helm chart can be used on any cloud. And in general, we try to partner as much as possible to make things as natively available in each cloud, but also not have to reinvent the wheel when we do it for another cloud. So reuse as much as possible, create as much as possible cloud agnostic and an abstraction layer, and then just have the implementation details for each cloud to change. And that's why that's what helps us be able to work on all the clouds without too much effort.
And then there's another question, which is there a need or initiative to pull together the a cloud workflow best practice or best patterns. And I don't know, maybe there is about best practices, but I think what I think is an issue and a barrier to using the cloud is if you're new to it, there's like a wealth of information and resources, and it can be all overwhelming. When again, I think you have better things to do. And maybe one way we can help the community is by with Erdal's benchmarking project to make some recommendations and give you some guidelines just to get going. I don't know. You want to add to that a little bit more?
I know, actually. So, by the way, if you would like to join the benchmarking work, please feel free to join us. We have tons of VMs that are ready to test, so feel free to join us. But yeah, I agree with you. So at the end, these kind of guidelines will be helpful for the users. If you have a limited budget, I have a limited budget in Microsoft too, by the way. So therefore, I need these kind of benchmarkings too.
All right, any other questions? Don't be shy. Or comments? Yes, ideas.
You can pretend the microphone is a genie lamp and make wishes of what you would like to see. Even vague wishes, like in your wildest dreams, what would be helpful?
So first of all, I think it's great that we have these community resources and like containerization and stuff. So I guess I have a use case where I'm trying to maintain a pipeline that depends on a lot of different, hopefully this question's like on topic, but I have like a pipeline that has a lot of these bioconductor dependencies, and I was just wondering if there's like a best practice or like what the recommended way to do things is for like maintaining specific package versions. So I know the container provides sort of like all the system dependencies, but if there's a way to sort of fix package versions and to make things like fully reproducible, I guess.
Oh, just to clarify, when you say pipeline, is it like, like a workflow in all, or is it like a, yeah,
it's like a Nextflow type thing with where components have run R scripts, I guess.
I mean, that is kind of, that's the idea of releases, I suppose, is that everything is all version controlled, unless you need specific subversions within that.
Like I don't know. Whenever I think of this, sorry, I'm going to mention Python. I always think about like fixing versions the way you can, for example, make like a requirements.txt, which is to specify this. Okay, that's what we're talking about. So like there, I believe there's like a similar package. Like what is it called?
I think like Nick's question can be translated to like, can you use renv?
Yes.
With the Bioconductor Docker image?
I think
the
so.
renv package is this one from RStudio.
Yeah, I think, I mean, we do base the Bioconductor Docker image on the Docker RStudio, so the community edition of RStudio built by the Docker team. So I think in theory you could use renv. I have not tried it, so I'm not going to say that I know for sure, but I think in theory you could. Another thing you could do is, instead of using just the Docker container that we have, if you really want to just like, today I decided this is the packages that I want them to never change again. You can create your own Docker file that starts from Bioconductor Docker and then adds a line that says run rscript e BioC manager install, so that you basically build your own image that has all the packages that you want. And once you have that image, it will forever stay with the packages at that version, even if they get overwritten and deleted, even Bioconductor disappears, that container image will still have the software. So if you really want to pin it down completely and, for example, even use it offline, I think that would be probably the best way to do it. Just extend the Docker image with the packages that you're interested in, and then use it without reinstalling.
Yeah. Okay. Awesome.
Sense?
Yeah, that makes sense. Thanks.
I just wanted to add really quickly. You may already be
totally aware of this, but the base Docker containers for Bioconductor, they all have different release versions that you can install. If that's, if you're looking for a particular release with a set of packages, you can just use that one.
I think Nathan has a question.
Yeah, it's actually kind of related. One of the challenges that I've had building images that have R packages in them is that if I put all these R packages in one image, then I can't necessarily use that image for a different application that needs like a subset of those, but different ones. So the same thing that led to containerization in the first place becomes a problem now with R packages. So I'm wondering if anyone is interested in or has any advice for solutions on things like containering individual packages, and then I guess providing ways of bringing in those individual package containers. Does that make sense, what I'm asking?
Yeah, I think it does. We don't currently have a public way of doing that. We are talking about surfacing basically the automated pipeline used to create these workshops. Is basically you can give it a list of packages and it will spit out a Docker container based on hours that adds those packages. And we have talked about surfacing that as something easier for everyone to do. One thing I would say though, if you're using the different Docker images on the same node, you can make, even if you make a separate Docker image for each package, when you run them, they will reuse the top layer. So how to explain, like basically the bulk, the like 90% or 95% of the disk space will be shared. So even if you have 300 Docker images, one for each package, and you run them all, and say each Docker image on its own is 2 gigs, they will have the first 1.9 gig as a shared layer. So if you run all 200, you'll see it only uses like 3 gigs of disk space because it's reusing that overlay file system.
Yeah, but you can't use them all at the same time for a combined analysis, right? For like a pipeline that needs 100 packages. Because you're talking about building them to test each one individually. Right?
No, you could add, if you want to run them all in a single container, yes, you would have to make a container with all of them. But if you're using any type of like Nextflow or anything like that, where you're dispatching, taking the results back and redispatching, you can basically have each container run a part of the script, give the results back, put that, RDS or whatever, like the R data into the new container, run the next step. It's not necessarily the best way to do it if you're doing your own pipeline. It's probably easier to make a bigger Docker image with all the packages that you need. But if you're using a workflow engine and your goal is to have very small containers that can be reused in multiple pipelines, for example, I think the way you would do it is use a workflow engine and have them give data back and forth between the containers. Or Redis.
I think we have time for one more question before we close up, but people have been wishing on Hopin, so.
Yeah, and this is not the question, so just want to add one more point to here. So if you want to build a workflow, it's not specific for GitHub Action, but if you are working with a cloud vendor, possibly another choice is to use the cloud storage to store all your package there. And then inside each container, you just create a shared folder and possibly like point to that cloud storage. And so that your container can use all the package stored in that cloud storage. So you don't have to put all the package inside each individual container. So just one more point here.
Yeah, that's a great point. And one quick comment. The versioning is very important in these kind of storage-based use cases. Therefore, I think maybe we can think about the versioning of these kind of new storage-based pools for the Docker images too, maybe. So let's discuss. Thank you.
Well, thanks everyone for all your comments and questions, and also for attending our talk. I hope that it doesn't end here, and that you'll continue to engage with us on Slack, or attend or become a member and attend future meetings. Here's our information on the screen. Please reach out to us if you have questions, comments, or use cases. We'd love to get you going. Thanks.